Kepler 452b is often described as one of the closest Earth cousins discovered so far. It lies about 1,400 light-years away and is roughly 60% larger than Earth, suggesting it may be a rocky super-Earth. The planet orbits a G-type star similar to the Sun, placing it within the habitable zone where temperatures could allow liquid water to exist. It receives about 10% more sunlight than Earth, which could lead to a slightly warmer climate. The host star is older than the Sun, meaning the system has had more time for potential biological evolution. Because of its size, Kepler 452b may have stronger gravity, which could help retain a thicker atmosphere. A stable atmosphere combined with long-term stellar stability increases the chances of surface water. Although direct observation of its surface is not yet possible, models suggest it could support Earth-like conditions. These characteristics make it one of the most compelling candidates for a potentially habitable world. TRAPPIST-1e is an Earth-sized planet located about 40 light-years away in a compact 7-planet system. It orbits a cool red dwarf star and lies within the habitable zone. Because it is very close to its star, it is likely tidally locked, meaning one side always faces the star while the other remains in darkness. This creates a permanent day side and night side. However, climate models suggest that a sufficiently thick atmosphere could redistribute heat across the planet. TRAPPIST-1e has a density consistent with a rocky composition, making it one of the most Earth-like planets in its system. The star is dimmer than the Sun, so the habitable zone lies much closer in. This allows the planets to orbit quickly, with TRAPPIST-1e completing an orbit in just a few days. Observations using advanced telescopes are focusing on detecting atmospheric gases. Studying this planet may provide clues about whether small rocky worlds around red dwarfs can support stable environments. Kepler 442b is considered a strong candidate for a potentially habitable super-Earth. It is located about 1,194 light-years away and is roughly 33% larger than Earth. The planet orbits a K-type star, which is cooler and less luminous than the Sun. These stars often remain stable for long periods, which can favor long-term climate stability. Kepler 442b completes an orbit in about 112 days, placing it within the habitable zone of its star. Its size suggests it may have a thicker atmosphere, which could help regulate temperature. The planet receives less stellar radiation than Earth, but still enough to potentially allow liquid water under the right conditions. Some habitability assessments suggest that planets around K-type stars may be especially favorable because they combine long lifetimes with relatively stable energy output. Although its surface conditions are unknown, its orbital and stellar characteristics make it one of the most promising candidates for a life-supporting environment. Kepler 1649c is a planet located about 300 light-years away and is very similar in size to Earth. It is only about 10% smaller, which suggests a rocky composition. The planet orbits a red dwarf star within the habitable zone, receiving a similar amount of energy to Earth from the Sun. This makes it one of the closest matches to Earth's temperature range among known exoplanets. It was rediscovered in 2020 when researchers reanalyzed older data and identified a missed signal. Because it orbits a red dwarf, it may be tidally locked, creating permanent day and night hemispheres. Red dwarf stars can also produce strong flares, which could affect the planet's atmosphere. However, if the planet retains a protective magnetic field and atmosphere, stable surface conditions could exist. Its combination of Earth-like size and favorable orbit makes it one of the most intriguing candidates for further study. Gliese 667cc is a super-Earth, located about 22 light-years away, making it relatively close in astronomical terms. It has about 4.5 times the mass of Earth and orbits within the habitable zone of a red dwarf star. The planet completes one orbit in approximately 28 days. Its higher mass suggests stronger gravity, which may help retain a thick atmosphere. This could allow heat to circulate even if the planet is tidally locked. The system itself contains multiple stars, which creates a complex gravitational environment. Despite this, Gliese 667cc remains within a region where temperatures could allow liquid water. Because it is relatively nearby, it is considered an important target for future telescopes. Observations may eventually detect atmospheric gases or surface conditions. Its proximity and potentially rocky composition make it one of the most accessible habitable zone planets for detailed study. Proxima Centauri b is the closest known exoplanet to Earth, located just 4.2 light-years away. It orbits Proxima Centauri, the nearest star to the Sun. The planet is similar in size to Earth and lies within the star's habitable zone. Because Proxima Centauri is a red dwarf, the planet orbits very close and completes a full orbit in about 11 days. This close distance likely means it is tidally locked. Red dwarfs are known for strong stellar flares, which can emit high-energy radiation. These flares could strip away an atmosphere if the planet lacks magnetic protection. However, if Proxima Centauri b retains a dense atmosphere, it could still maintain moderate temperatures. Its proximity makes it a major focus for future missions and advanced telescopes. Scientists hope to directly study its atmosphere and surface conditions, making it one of the most important targets in the search for nearby habitable worlds. Kepler 186f is historically significant as the first Earth-sized planet discovered in the habitable zone of another star. It is located about 500 light-years away and orbits a red dwarf star. The planet is similar in size to Earth, suggesting it may have a rocky surface. It receives receives less energy from its star compared to Earth, but still within a range where liquid water could exist. Because the star is cooler, the planet likely orbits closer and may be tidally locked. Despite this, a suitable atmosphere could distribute heat and stabilize the climate. The discovery of Kepler 186f demonstrated that Earth-sized planets in habitable zones are common in the galaxy. Although its exact surface conditions remain unknown, models suggest the possibility of oceans. This discovery marked an important milestone in the search for potentially habitable worlds beyond our solar system.